Okay, so what we are looking at today is the same exact type of problems, basically a limiting reactant problem. So one where I give you the amount of two reactants and I ask you how much product can be formed. But the difference here is that instead of me just giving you mole numbers, we are giving you the numbers in mass, which really means the same thing that we did last the first half of the chapter we're going to be doing again, which means no matter what we're given, right, we're starting with, whether we start with mass or volume, if we start with particles like number of atoms, if we can convert it to moles, and then from there use the ratio from the balanced chemical equation to find the moles of the product, and then whatever the question is asking us about that product. Okay, so here's the first example that we're going to do. I think in your notes this might be number 49, I see. And so this is a synthesis reaction between sodium and chlorine. Sodium's going to lose electrons, become positive. Chlorine's going to gain electrons and become negative. So sodium is oxidized and chlorine is reduced. So it says we plan to run this reaction starting with 53.2 grams of sodium, and 65.8 grams of chlorine. So we're just going to do basically the same thing that we did last chapter, where we're going to do a 3 parentheses stoichiometry problem, starting with grams, and then converting to moles, and then moles of the other product, the product that we want, sodium chloride, and then grams of sodium chloride. So I'm going to start with this 53.2 grams of sodium. And of course, converting to moles, we would have 1 mole of sodium on the top, and the molar mass from the periodic table, 22.99 grams on the bottom. And then according to the balanced chemical equation, 2 moles of NaCl will require 2 moles of sodium. And then the question is asking for grams of sodium chloride, so I have to convert from moles to grams. And put this in my calculator, 3 significant figures here, I get 135 grams of sodium chloride. So what did I just figure out? If I use up all the sodium and I have unlimited chlorine, I can make 135 grams of sodium chloride. So now let's do it with the other reactant. Beginning with the mass of the chlorine, find out how many grams, the mass of NaCl, that could be made. So this is just like the beginning of the chapter, 65.8 grams of chlorine, right? The first thing we can do is we convert to moles. 1 mole of chlorine has a mass of 70.90 grams. I know that from the periodic table. And then here I'm using the coefficients from the balanced chemical equation. And then again, converting to the number of grams of sodium chloride that can be produced. And this tells me that if I use up all my chlorine and I have unlimited sodium, I should be able to make 108 grams of sodium chloride. And very similar to what we did a few days ago, whichever one gives us the least amount of product is going to be the maximum amount of products that we can make, because that reactant that produced that much would get all used up. So which calculation predicted the least amount of product? This second calculation, right? The one in which we used Cl2 as my starting material. So that means that was my limiting reactant. The 65.8 grams of chlorine was my limiting reactant. What was my theoretical yield? That's that 108 grams of NaCl, right? Yield must be a product. NaCl is the product. So now let's write a concluding statement. So since the limiting reactant here, so 65.8 grams of chlorine will produce the least amount of product, it must have run out first, and thus was the limiting reactant. only 108 grams of NaCl can be made before the reaction stops and the chlorine runs out. Okay, and we're going to talk about one additional concept here. We've talked about this actual yield before, right? The theoretical yield and actual yield both are with this word yield, right? Theoretical yield we talked about was how much should be able to be made, right? That's what theoretical means. Means if everything goes right, how much should be able to be made. The actual yield is how much you actually made. Always has to be a product. And some of the examples that we give is like with the pancakes, right? So you'll have a recipe, it says you'll be able to make 5 pancakes, but then you actually do it and you only made 4 pancakes. Or a cookie recipe says it should make 24 cookies, but when you actually did it, you only made 22 cookies. That how many you actually made, the 4 pancakes or the 22 cookies, that was your actual yield. Your theoretical yield is what the recipe said you should be able to make. Your percent yield is a percentage that relates those two. It's the formula for percent yield is actual yield divided by theoretical yield times 100%. This is important because if we are making a specific substance and I have a process to do it, a balanced chemical equation that explains how you can make this, I want one that has the highest percent yield possible. So if I look at the next question here, number 50, when I did this reaction, I only recovered 86.4 grams of NaCl. What was my percent yield? And again, remember, now that we have a formula, we're going to be writing the formula all the time, percent yield, and I will often abbreviate it, actual yield over theoretical yield times 100%. In this question, right, I gave you the actual yield, and most of the time I'm going to give you the actual yield. It says I only recovered, right? Recovered means get back, right? I was only able to make 86.4 grams of NaCl. Remember, on the previous page, we saw that with using chlorine as our limiting reactant, I should be able to make 108 grams of NaCl. And when I do this division, of course, the units cancel out. That's why percentages don't have units, because the units will always cancel out, because these should be of the same substance. And they should be, the substance should be one of the products. Okay. And 3 significant figures here. This actually comes out to be exactly 80.0%, right? 3 significant figures. The 108 also had 3 significant figures. Okay, so if we go back and summarize this problem, the question was very similar in that I gave you the amount of the 2 reactants, but this time in grams. I did a 3 parentheses stoichiometry problem to find out how many grams of the product each could make. And of those, I chose the lowest number, the lowest amount in grams of product that could be made, because that tells me that when 65.8 grams of chlorine is used, the reaction will stop. So there's no way I could make 135 grams. So the 65.8 grams of chlorine was the limiting reactant, and 108 grams of NaCl was the theoretical yield. And then the second part of the question gave me the actual yield, and I was able to calculate the percent yield there. Okay, we have a few more examples to go through, and we'll be doing videos for each one of those. So if you feel like you are ready to do some on your own, you can try these next few and then check your answers with the notes, or you can move on to the next video.